Okay, quick one here. You need to reference your published values. Unless you tell your readers where they came from, they're going to assume that you made them up. In our case, we got them from the packets of the aspirin, but only one or two of you have actually taken a photo of the picture and put that in. Taken a photograph of the packet. You need to do that because otherwise you're saying the published value is 0.05 grams and you're not referencing it in any way, and you know from extended essays, etc., 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 that's not okay. If you're doing a different experiment and you get your values from the internet, then you also need to think about the quality of your source. Is it an internationally recognised source, for example, the Royal Society of Chemistry, or is it just on someone's blog? And how do you know in this case that their values are reliable? So think about where you're getting your published data from. It doesn't have to be a long piece of information. You don't have to write a lot. Maybe one sentence. I found this value from, give a reference, and then maybe say, I think this is reliable because blah, blah, blah. If it's on the packet of the aspirin, then you don't need to explain. I think that's fine. Okay, this is an important one. I've called this the error of you. So you guys are basically obsessed with telling me that your equipment wasn't very accurate. So my burette, my pipette was not very accurate. If I had a more accurate one, my results would be better. Some of you want to tell me that the temperature and the pressure changed between one day and another, and that must have had a really big impact on your results. My question to you is, who is using the burette and pipette, and how accurate are they? Well, you might think I don't know the answer to that question, but I do, because in your raw data, I can easily see how similar or different your results were. And unless they are extremely precise, remember precision is when they're all very close together, then I would consider that it is you who is causing the uncertainty and not your equipment. Now, I don't want you to feel like you have to change your results to try and make them more precise, because really in science we're bothered about what we actually see. So what I've written down here is that in life, usually we're asked to defend ourselves, like, why have you not done that correctly? Why have you not done that correctly? In science, we don't want to do this. It's not about making yourself perfect. It's about trying to be objective. And that means taking what you have and presenting it as it is and trying to explain the problems. Remember, if you've got no problems, you haven't got a good conclusion evaluation. So you may as well leave yourself with some problems to explain. Although, obviously, you try and be as accurate as possible when you're doing your experiment. This means if you were the cause of some of the problems, then say so. My results don't seem to be very precise, and therefore maybe I could have tried harder to make my results really accurate by being a bit more careful with the burette, for example. Now, this experiment is a little bit interesting because, in fact, lots of you had different masses of tablet each time, and so that would mean that you wouldn't necessarily be expecting some really precise results where they're all exactly the same as each other, because you didn't start with the same mass of tablet to start with. So it's a little bit more complicated, but you can talk about that. Don't forget, doing this simply means that you have evaluated your procedure correctly and identified the need for some improvement, which is the basis of the conclusion and evaluation. Don't feel bad about doing that, but be aware of using these ideas where you're telling me that your equipment is not good enough, because as an examiner or as a moderator, those things pop up straight away and tell me that you have not really understood where the errors are coming from in your experiment, because burettes and pipettes are some of the most accurate equipment that we can use in the lab.